So in this video, we're going to talk about something that's very important to understanding reaction mechanisms within organic chemistry, and this is the idea of the mechanistic arrows. So whether or not it's required, I'd really recommend you get this book or whatever version of this book's going on right now. It's called Pushing Electrons. About $5 or $10, okay to get a used copy. The thing is that it's going to teach you how to draw these mechanistic arrows better. Now, it's a book I didn't really use in Organic 1, but Organic 2 I found it really helpful. And if I could go back in time and tell myself, hey, you should really go read this book, I would go do it, because this is really fundamental to understanding what's going on with organic chemistry. Organic chemists really rely heavily on Lewis theory because Lewis theory emphasizes what happens when electron pairs are moving, and that's what's going on here. So let's look at enol-ketone isomerization. What we're going to have happen here is that the oxygen here is going to grab a hydrogen off this carbon and create a double bond here. And so we're going to convert this ketone into an enol, which is a double bonded carbons with an alcohol attached to them. And the way it's going to do this is it's going to move electrons around. Now, whenever we draw an arrow, the arrows are going to refer to electrons, and it's going to point to where they're going to in terms of making a bond, or to the atom if we're looking at an acid-base reaction. So in this case, we're going to draw an arrow from the lone pairs on oxygen to hydrogen. And what this is saying is that we are now forming a bond between oxygen and hydrogen using these lone pairs. So these double dots here are going to be converted into a straight line. Now, hydrogen can only have one bond in organic structure, so what's going to happen is that these electrons are going to go down to carbon. Hydrogen's going to give up these, create 2 electrons on carbon. Next step is that these 2 electrons are going to come between these 2 carbons and form a carbon-carbon double bond. This carbon-carbon double bond creates too many electrons with carbon, so what carbon's going to do is going to give up these 2 electrons in this bond between carbon and oxygen to form a new lone pair on oxygen. Now again, the emphasis here is what's going on with the electrons, and that's what the arrows are really trying to say. When we take double dots and we draw a line from them to an atom, we say we're forming a bond with that atom. When we draw a line from a bond to an atom, we're saying that we're taking that bond and creating lone pair electrons on that atom. When we draw a line from an atom to a bond, we're saying that we're now creating a double bond or a triple bond. When we draw a line away from a bond to an atom, again, we're creating lone pairs. So what is this going to look like? Well, we've still got our carbon backbone, R, C, C, H, and H. Now, we're forming a bond between the oxygen and the hydrogen. So that's that arrow there. We're taking these electrons, bringing them to the carbon, using that to make a double bond between the carbon and the carbon. So that's these 2 arrows there. And honestly, some books will just kind of skip this, and they'll just draw that. But the end result is the same. Now we're also taking this bond here and creating lone pairs on oxygen. So this is the end result of what we've drawn here in terms of mechanistic arrows. So what you need to be able to do and figure out on your own, as well as figure out from diagrams, is what bonds are being made or broken and what the end result's going to be. Now, if I were just to draw this as a new organic student, seeing these arrows, I would say, okay, I form a bond, and form a lone pair, and then would clean this up to get this structure. But again, it's kind of experience that tells you these things, but again, it's being able to read these arrows. So this is kind of your introduction to using mechanistic arrows, and hopefully this kind of clears things up for you when you start seeing this in later videos.